Okay. The rest of the chapter is pretty easy. The rest of the chapter deals, the second part deals with the population mean when we do not have the value of the standard deviation of the population. So when sigma is unknown. In this case, we're going to use the t distribution with n-1 degrees of freedom. So exactly the same thing that we used in the previous chapter. And of course, my test value is going to be equal to x bar minus mu0 divided by, instead of sigma, we don't have sigma, but we should have the standard deviation of the sample s divided by the square root of it. That's it. That's it. That's the only thing that really changes. So let's do problem . This is problem 23. Okay, let's do problem 23. It says hypothesis that mu is less or equal to 12. Okay, yeah. Mu is less or equal than 12 against that is greater than 12 as the alternative hypothesis. A sample of 25, so n is equal to 25, provides a sample mean x bar equal to 14, and the sample standard deviation s is equal to 4.32. Okay, compute the test value, use the t-distribution. Okay, alpha is 0.05. Okay, so the first thing that we need to know is, after we formulate the hypothesis, we need to know what type of test is this. This is, again, a one-tailed test, but this now is an upper tail test. Okay? And we have alpha, this has to be 0.05. What is this critical value over here? Okay, instead of going to the Z table or going to whatever we already know, we have to go to the T table or this T distribution and look for n-1 degrees of freedom. 25 minus 1 is 24. And we need to know what is this critical value over here. So we have to deal with the 0.05, and that is 1.711. So my critical value, 1.711, positive because it's in the right side. If it's a lower tail test, in this case, you use the negative 1.711, again, because it's a symmetrical distribution with the mean equal to 0. So it has to be the same thing, the right side and the left side. Okay, so we already have the type of test, and we already have the critical value. What we need to do now is to compute our test. The test value, and that is equal to x bar, 14 minus mu0, that is 12. That is mu0 is the constant that you are comparing the population parameter against. Divided by S is 4.32 divided over the square root of my sample size, the square root of 25. And this is 2.6 2.31. 2.31. Okay, now where is that 2.31 in my rejection fail to reject zone? The 2.31, of course, is over here. This is the 2.31, and of course it's in the rejection zone. So my conclusion is to reject the null hypothesis and say that we do have a statistical evidence in favor of the alternative hypothesis that the mean is really bigger than 12. Okay, now what happened when we use the p-value approach? Since the tables do not give us, the t-tables do not give us the exact p-value, either you use a statistical package or any other mean to calculate the t, or you go to the tables and find where is the 2.31 located, where the degrees of freedom is 24. The 2.31 is located between the 0.025 and the 0.01. So you know that the p-value is between 0.025 and 0.01. That's the only thing that you may see in your tables, because the 2.31 is between the 2.06 and the 2.49. So it's between these two values. So the area is between 0.025 and 0.01, or vice versa, guys. I'm sorry about that. The 0.01 is less. So now that's the only thing that you can do to get the p-value from the tables. Now the alpha is 0.05, right? Alpha is 0.05, and although that you cannot have the exact p-value, you know that either way, that any value between 0.01 and 0.025 is less than 0.05. So the conclusion is reject. Reject the null hypothesis, and you have the same type of conclusion that using any of the approaches, the critical value approach and the p-value approach. That's it. That's it. The last part of the chapter is about the population proportion. Hypothesis testing about the population proportion. And you have exactly the same situations. We may have a two-tailed test. We may have a one-tailed test, upper lower. So it's about the population proportion. And when we are dealing with the population proportion, we have what? We're going to use z, but the test value is going to be p bar minus p0 divided by the square root of p0 times 1 minus p0 divided by n. That is what is important about hypothesis testing about the proportion. Now, let's do an example. It's exactly the same thing. Exactly the same thing. Okay, chapter 9. And this population proportion is exactly the same thing. We either may have a two-tailed test or one-tailed test. Let's do problem 35. We have the hypothesis P is equal to 0.2, the null, against the alternative that is not equal to 0.2. Okay, now what type of test is this? Is a one-tailed or is a two-tailed test? Since we have equal and not equal, we do have a two-tailed test. Okay, that's the first thing that we need to know. What type of test is that? It's a two-tailed test. Now, we are dealing with alpha equal to 0.05. Alpha is equal to 0.05. We should have the p, the proportion of the sample p-bar that is equal to 0.175, and we should have n, that is the sample size, and it says that the sample size is 400, and that's it. That's all we need to know. And we are going to use again the two approaches. So alpha is 0.05, so it means that since we are dealing with a two-tailed test, this is alpha divided by 2, this is 0.025, and this is 0.025. In this case, my critical values are negative 1.96 and positive 1.96, and the rejection zones are to the right of the positive 1.96 and to the left of negative 1.96. So what is the test value? Is p-bar 0.175 minus the p0. P0 again is the constant that we are testing or making our hypothesis about the population parameter against. That is the 0.2 divided by p0, that is the same one that we are dealing with. 0.2 times 1 minus p0 is 0.8 divided by n, that is 400, and everything square root. So what is this value? I don't know. Negative 1.25. Okay? Okay, negative 1.25. Where is this negative 1.25 located in my chart? Negative 1.25 is located right in here. This is the negative 1.25, and this is the fail to reject zone. Remember, the rejection zone is the shaded area, the fail to reject is inside. So this is a fail to reject. So what is the conclusion? The conclusion, we fail to reject the null hypothesis, and we say that we do not have statistical evidence in favor of the alternative hypothesis that is not equal to 0.2. So it may be or maybe not, but we do not have statistical evidence to support the alternative hypothesis. Okay, let's do this exactly the same thing, but using the p-value approach. Okay, what is the p-value? We have the test value that is negative 1.25. Go to the table. 1.25 is 0.1056. Right? 1.25. Let me recheck that again. 1.056. Now, this is not the p-value because we are dealing with a two-tailed test. When we deal with two-tailed tests and we are computing the p-value, we have to multiply times 2. So the real p-value is going to be 0.2112. That is the p-value. That is the p-value. Now, is the p-value less than 0.05? That is my alpha is 0.21. Less than 0.05? No, it is not. So we conclude that we failed to reject the null hypothesis. So both conclusions should, both approaches should lead you to the same conclusion. That's it. That's the whole chapter. Pretty easy and pretty simple.